Now we are start with Paraskevi Nomikou. Is a leading marine geologist specializing in submarine volcanism, seafloor morphology, and marine geohazards in the Aegean region. She has participated in more than 80 oceanographic expeditions and leads Santorini, the seafloor observatory monitoring the Kolumbo submarine volcano and supporting hazard mitigation for Santorini. Her recent work focused on the assessment of tectonomagmatic risk northeast of the island. She's dedicated to the advanced marine technology in research and inspiring young scientists, especially women, to explore deep ocean. Professor Nomikou received the 2025 Fisher Medal, and she has been nominated to a SCAF for her expertise in submarine geomorphology. So welcome to the floor, and we
Okay. Can you hear me? Yes, okay, thanks. Thanks for the invitation. I wish I was there. I'm so glad that I can participate online, but I wish I was there to share my knowledge with all of you. And I'm so glad that I can see a lot of young scientists that they have passion on submarine volcanism. And we will travel not in the Atlantic Ocean, but we will travel in Santorini, the famous volcano, the worldwide volcano. So I will show you what our results, and especially our results during the recent seismic crisis in the submarine area very close to Santorini. In Santorini caldera, but also we have a very active volcano named as Kolumbo. It's extremely active, and we have found a lot of hydrothermal vent fields at the crater floor at the depth of 500 meters. So let me share my screen. We have been working in this area many years now, starting from 2001. And we just published a paper in Nature explaining what happened during the recent seismic crisis. And for us, it was extremely important because all of us, we are oceanographers, that we have a lot of marine data. We have a lot of marine data in a very active volcano like Santorini. Just now you can see a very beautiful photo of the caldera of Santorini, one of the largest caldera of the world that is flooded. It's full of water with a dimension of almost 11 kilometers north to south. So as a background, here in Greece, in the South Aegean Sea, we have 4 different volcanic groups, starting from here, from Methana in the Saronic Gulf, and then we have Milos, Santorini, and to the east we have a small volcano named as Nisyros. But close to the onshore volcanoes, we have also submarine volcanoes, and we have explored these volcanoes many years now. The most active part of the submarine volcanism is close to Santorini, and I will show you why. But all of these volcanoes are located within grabens, tectonic grabens, and they are bordered with active fault zones. So the volcanism and the tectonism are very well known correlated. So, and all the faults are reacting as pathways for the fluids to coming from the magma chamber up to the surface. And of course, here, as I said before, this is Santorini, the famous volcano, but close to Santorini, we have found a lot of submarine volcanoes. Santorini is located just in the middle of the Hellenic volcanic arc, and our volcanoes is completely, the geodynamic position of our volcano is completely different for your volcanoes because we are in the subduction zone. The African plane subducts below the European plate. So for us, this area, in Santorini specifically, we have 3 different volcanic groups, started from the west. This is Christiana. This is the oldest volcanic group in the area, and the age is almost 1.2 million years before. And most recently, due to the IODP 398 expedition, we have found a huge submarine caldera in the northern part of Christiana. So everything started from the seafloor. That's why the submarine volcanoes are very important also for us. Of course, Santorini caldera, you can see the Santorini caldera, and we have also Kolumbo volcanic field to the northeast. Kolumbo is the largest volcano of the area. It's very active and has been activated in 6050. But except of the volcanoes, we have a lot of fault zones. These white dot dashes, you can see that these are the faults. And especially here, our Morgos fault is one of the most active faults that we have in Greece that was activated in 1956. We had a very huge earthquake with a magnitude of almost 7.6. So we have a lot of distractions in Santorini and in other islands. So you can imagine in an area that we have volcanic eruptions, landslide, earthquakes, tsunami. The 1956 earthquake, the run-up of the tsunami was almost 25 meters. We name this area as a supermarket of natural disasters because we have everything. And especially all the main events started from the seafloor. So as the volcanic tectonic history, I think that we all very well known about the Minoan eruption, the famous Minoan eruption that destroyed the Minoan civilization and dated approximately 600 BC. So approximately 3,600 years before. You can see the high explosive was almost, the wave was almost 7, and you can see the volume, the magma volume of this eruption. We know the magma volume because we have merged the onshore and the offshore data. Then another important eruption was within Santorini caldera, the eruption of Palea Kameni, 726. And if you have ever visited Santorini and you go to Palea Kameni, you can see only a very small lava flow. And you can imagine that, okay, this eruption was not very important. It's completely different because when we drill with the JOIDES resolution within Santorini caldera, we found a huge layer of pumice from that eruption within the caldera, but also outside of the caldera. So the volume of the producing volume was much more larger than the previous thoughts. So we need to rethinking about the Kameni eruptions. Then we have the big eruption of 160 of Kolumbo. That was one of the largest eruptions, submarine eruptions that we have in the Eastern Mediterranean in general, because almost 70 people who died due to the poisoned gases. And we had a tsunami with a run-up of almost 10 meters in the eastern part of Santorini, Veias 5. Then a big earthquake, as I told you before, the magnitude of 7.5, 7.6 at 1956, and almost 20-meter tsunami. Then we have one seismic crisis in 2010 and 2011, the previous one in 2003, that we have some Santorini inflation. We have a magma, emigration of the magma within Santorini caldera, but after 18 months, the magma stopped moving and we didn't have any volcanic eruption. And of course, the most recent crisis in 2025, that was starting from June 2024 and ended to March 2025. And we will tell you more about that because now we know that there was a dike emplacement. Look, offshore Santorini. So you can see that the area, the submarine area around Santorini is extremely important to us. So the motivation of the study, was that, of course, we had a lot of earthquakes starting within Santorini caldera, as you can see here, within Santorini caldera for almost 6 months, and all the earthquakes then moved outside of Santorini caldera in the area close to Kolumbo, but then also in a very small island named as Anidros. There were more than 30,000 earthquakes in a period of almost a month. Why Santorini? Why people know Santorini? Because it's a very touristic place, but more than 3 million tourists we have every year. And I was born in Santorini, so it's very difficult during the summertime. But also in February, when we had the seismic crisis, even though the scientists, they didn't say to the people, please evacuate the island, because during the seismic crisis we had two commits that they have a lot of organization, but a lot of meetings weekly, more than two times. We didn't say that you need to evacuate the island, but the people were terrified because they felt an earthquake every 10 minutes. And of course, we had the state of emergency. There were a lot of, from the management body of the main government, they were there in Santorini to help the people. So here we are lucky because in this area, so everything everything started from the pre-crisis. As I said before, we had a lot of seismic stations installed in Santorini, so we were lucky because we have a lot of seismic data. The earthquake started within Santorini caldera along the Kameni line. So at the beginning, all the scientists believed that, okay, we are going to have a new unrest, a new seismic unrest, as we had also in 2011, 2012. But everything changed, and then we have the crisis of 2025, and we had the movement of all the earthquakes outside of Santorini caldera. Hopefully, as I said before, we had a lot of seismic stations and a lot of GPS stations in Santorini, but due to the seismic crisis, all the seismologists, they install a lot of seismic stations in the other islands, and of course the GPS stations that they give us the movement. Even though we are in the subduction zone, we know that the geodynamic position of Santorini belongs to the subduction system, but in this particular area, northeast of Santorini, we have extension due to the active faults. There are so many faults in this area. And as I said, we have at the beginning from July 2024 up to January 2025, in particular 27th of January, we had a lot of earthquakes within Santorini caldera. So we have an uplift, okay, Santorini uplift with a shallow chamber and with the inflation of the magma almost 0.01 cubic kilometers. Then we have, and also you can see the movements of the GPS, okay, that they are showing that we have inflation within Santorini caldera. So the Mogi source was within Santorini caldera. But then they had a lot of similarities with the situation that we have in 2011, 2012. We had increase of seismicity. All the earthquakes were along the Kameni line here, very close to Nea Kameni. And of course, at that time, we had two pulses of the magma. So you can see here that during that crisis in 2011, 2012, a lot of scientists, they were compared and they measured the magma volume that was moved during that crisis, but also that was not the level, they didn't keep the level that, okay, now we are going to have a volcanic eruption. Hopefully, also due to the IODP expedition, we have a lot of seismic data, multi-channel seismic data in this area, around this area, and especially also here in Kolumbo. Here you can see these rectangulars. These are the three, also we obtained 3D seismics in Kolumbo and also in Amorgos fault. But also if I will add more lines, you will see that we have covered this area many years before. But in December 2024, we were lucky because also we were obtaining more multi-channel seismics in this area. And of course, we also obtained 3D seismics along Amorgos fault. We were lucky because we were there on board Maria Merian, the German vessel, but we didn't know that the seismic crisis has just started in December. And we noticed that we had some earthquakes within Santorini, but we said, okay, this is normal, it's an active volcano. And of course, we also used a lot of ROVs, a special ROV, the MOLA, and we mapped the hydrothermal vent fields within Santorini caldera. This is one of the options of the active hydrothermal field of caldera that is located in the northeastern part of Santorini. But the most important thing during that time is that we deployed OBS inside Kolumbo and outside Kolumbo. So we deployed 8 OBS, 3 inside and 5 outside Kolumbo. And we live there. We have another cruise now in a month in order to recover the OBS. So all these OBS, they measure the seismic activity of Santorini, and we were lucky because that was the beginning of the seismic crisis. So you can see the location of the OBS. The most important ones were the ones that they are inside Kolumbo. And I will tell you what was happening. So the crisis. We had a lot of earthquakes starting at the 27th of January, when we have all the earthquakes that they were located outside of Santorini caldera. Then we realized that something happening. We were afraid of the Kolumbo, okay, because we know that the Kolumbo is very active. And then that also for the first time that the Greek government asked for the scientists, also with the prime minister, to inform the people, inform in the TV, inform everybody what is going on. And of course, under the Multimarex project, the German project, in collaboration with the Greek University of Athens, we installed this very portable, very small but portable OBS within Santorini caldera in order to collect more seismic data. And the German colleagues, the Multimarex in general, they are in collaboration with the Greek committee. They're giving some reports in order to have one voice. This was extremely important. We tried during our meetings with the committees, we tried to have one voice, but you can understand that the journalists, they wanted just to sell the news, and Santorini is a very well-known, famous, and everybody had a different opinion of the final decision of the committee. So there was a little bit confusion, and especially for the people of Santorini, that they were terrified because of the earthquake activity. So to the right, down to the right, you can see all the seismic lines. We tried to analyze the data. And of course, we knew that the whole area, northeast of Santorini, has a lot of fault zones. And of course, all the structure, this is the anhydrous reeds. All these anhydrous reeds that you can see here, the earthquakes, the epicenters of the earthquakes, all these, we have fault zones that they reach the sea bottom, but also we have a lot of buried fault zones. And except of the fault zones, we have a lot of volcanic cones. Volcanic cones northeast of Kolumbo. We have measured almost 26 volcanic cones northeast of Kolumbo, and they are in correlation with the activity. So we were trying to figure out what was happening, because according to the mechanism, the earthquake mechanism, the focal mechanism, all the earthquakes were tectonics. Okay, but we try to find out the source of this activation. So we produced, analyzing all the seismic data, we produced the offshore tectonic map of the area, and also we give this data to the commits. So you can see that the whole area, you can see all the black lines that are full of faults. One of the most active parts is here, the Amorgos fault, but of course here is also the anhydrous faults. And all the earthquakes were located in this area between Santorini and anhydrous. At the beginning of the seismic crisis, we have also, under the framework of the Santori project, Santori is the seafloor observatory of Kolumbo. We deploy we have an AUV glider in order to figure out at the 2nd of February and then at the 13th of February. And we have also installed a gamma radiation sensor, because we wanted to measure also the radioactivity within Kolumbo, but also to realize the radioactivity levels, but also to realize the turbidity. And we realized that the turbidity during the seismic crisis was very, very high. And even though we knew that due to the vents that they are in the crater floor, the turbidity is very high at the crater floor, now during the seismic crisis, the average turbidity was from 200 meters up to 400 meters. So Kolumbo was very, very active during the seismic crisis. But in 2015, we had, with Marcus Lanxess, we deployed OBS, and we had an active seismic experiment. So we knew the geometry of the magmatic chamber, and we have published a lot of papers with the University of Oregon. So we knew that close to Kolumbo, in the northeastern part of Santorini, except of the chamber that is below Kolumbo, there is another medium magma chamber that can also feed the shallow magmatic chambers of Santorini and Kolumbo. So at the beginning of the seismic crisis, the marine geologists that we are full occupied with the area, we understood that, okay, even though the faults are, the earthquakes are tectonics, the source must be somewhere in the deeper part of the planet. So in March 2025, under the framework of Hydromox, using of NOC, we used the Discovery, the vessel, and we recovered the OBS within Kolumbo, but also that was the first dive using the ROV inside Kolumbo. I was I was very excited to see if the vents that we found in Kolumbo, they were there, if they have been destroyed. So we make a lot of measurements, temperature measurements. We took a lot of push core samples. We measure also the radioactivity. You can see here, and also we did electromagnetic survey within Santorini caldera and outside within Kolumbo. This is, when we are talking about the active hydrothermal vent field within Santorini. In 2012, we have found some pools, small pools, that they are full at the depth of 230 meters, that they are full of methane and CO2. In December 2024, we found more pools in the specific area. You can see here to the right, and all the pools are surrounded by bacterial mud, ridges of bacterial mud. And the most important thing is that in December 2024, these pools were full. In the March 2025, almost most of the pools were empty after the seismic crisis. In Kolumbo, these are the active vent field of Kolumbo. It's full of chimneys. We have found more than 200 chimneys that they are composed by rare materials, but also it's covered by bacteria. The gases that are coming out are 99% of CO2. The temperature in March 2025 was almost 256. The usual temperature of this chimney is almost 230, 220. So you can see the activation of the vents. So we took a lot of samples and temperature. But the most important is that also we deploy hydrophones, and you can hear the noise of an earthquake. So we recorded earthquakes in March 2025. Even though the seismic activity was less, we didn't find a lot of differences on the slope, so we didn't find a lot of landslides within the inner crater floor of Kolumbo, but also the activation was very, very high. But the most important thing is that we recovered the OBS. And the OBS, we analyzed the OBS data, and the OBS show us that we have a subsidence within Kolumbo. So the whole area has been subsided, almost 30 centimeters. And also we have created a geological map, and we realized we know what are the evacuation zones. So we know that the zone 1 is the exclusion zone around Kolumbo. So if something, if a volcanic eruption started, nobody can enter this zone 1. So having all the data, having seismic tomography results, having GPS seismic data, having also OBS data, we realized, and also using the AI in order to relocate all the earthquakes, we realized we analyzed more than 30,000 events in February 2025. And it was divided in some phases. First, we have some deep events, started at the 27th of January at the depth of 18 kilometers. That was the depth of the magma chamber. So we had the upward migration to the northeast and at the depth of 10 kilometers. Then we have more shallow earthquakes in the upper crust above 12 kilometers. And of course, we had this subsidence that we realized also from the OBS analysis. Then you can see here that during that phase, the phase 3, approximately at the 14th of February, 15th of February, we had very, very shallow seismicity up to the depth of 3 kilometers. The focus seismicity was almost 3 kilometers, and we had a large magnitude earthquakes up to 5. The biggest one was 5.3. So all the activity was around Nisiros. And then at the end of the seismic crisis, we have a little bit, again, no seismicity, but also a lot of earthquakes. You can see also that the people from the colleagues from IMO, for Icelandic Meteorological Office, they play some models, they create some models. They found that the Mogi source was very close to Kolumbo, and we had a dike intrusion. You can see here the different phases and the distance from Santorini. The most important phase was phase 4, when we have the dike intrusion. You can see the dike migration velocities. And of course, this is the model. We know now that the Mogi source was very close to Kolumbo. At the beginning, we had an inflation, but then we had a deflation due to the dike intrusion with a length of almost 13 kilometers. And the dike started, the migration started from the depth of 18 kilometers up to 3 kilometers northeast of Santorini, in the direction of northeast-southwest. You can see also that all the GPS arrows show this the direction of the dike prolongation. So as a conclusion, at the beginning of the volcanic crisis, we have increased almost a very small increase of CO2 within Nea Kameni, where we have inflation. So we had a surface uplift and increased seismicity in the caldera, but due to the 3D seismic results, we have found the mid-crustal magma storage system that feeds, okay, the magma chamber of Santorini, but then we have the connection. This is very important because before the seismic crisis, we thought that we have two different magmatic chambers below Santorini and below Kolumbo, but this magmatic chamber had not been connected. This is not true because they were fed by this magma, mid-crustal magma accumulation at the depth of 18 kilometers. So we have the seismicity occurred at the tip that the boundaries of the dike ruptured. Shallow crustal normal faults were activated. We have found a lot of faults activated by stress and fluid pressure changes. We have a dike intrusion in the area close to Kolumbo, but in the area with anhydrous. Anhydrous is composed by limestone. That's why at the beginning we couldn't realize, and especially the people that they are not oceanographers, they couldn't realize what was happening. And the concurrent inflation of a shallower mid-crustal melt reservoir led to subsidence, which was measured not only in Kolumbo, but the whole area in Kolumbo and Santorini. So the summary is tomography shows us multi-level magma storage system, complex interplay between dynamic dike emplacement and extensional tectonics. Even though we are in the subduction zone, Greece is in the subduction zone, deep storage is feeding dike intrusion, as I told you before, from the depth of 14 kilometers depth, hydraulically linked magmatic system over various crustal levels below the Santorini and Kolumbo volcanic system. That was extremely important. Pre-crisis inflation we had in Santorini for 6 months, and of course, the vertical drainage of shallow reservoir. So muchas gracias, thank you so much, and I wish that the next year I will join you, or I will be there in person. Thank you so much.
Thank you, Avi. Thank you very much. We contact with you after the end of this first session, so please wait a little bit for us, and thank you very much.
Thank you so much, Evi. Eugenio here. Thank you so much. It was a pity that you couldn't come here to Tenerife, but it's a pleasure, real pleasure. I know that you're a really busy person, so thank you so much for attending this IV International Vulcana Symposium. Thank you so much. And I will like to ask you later some questions, please.